Okay. All right, here we go. This is our quiz tomorrow. There are 62 students in a group, so I'm going to put 62 right here to remind myself that there are supposed to be 62 people in that box. 25 of them like Halloween. I'm just going to make a note of that over here. Can't put that in my picture yet. We'll talk about why in a minute. 36 like the 4th of July. And 36 like Valentine's Day. Exactly 6 like only Halloween, 10 like only the 4th, 14 only like Halloween. Wait, that should be Valentine's Day. So change that second. 14 like Valentine's Day. Find the probability of choosing one student. Wait, I did a terrible job with this. I got to make sure I did better on quizzes too. I left something important off that I need to put in there. Okay. All right, so another piece of information that we have to add to the problem is that 7 like all 3. That needs to be added in there. I left that out. Oh, I hope I didn't leave it off of all of them. But I bet I did. 7 like all 3. Okay? So let me back up. Let me read through this again. So 25 like Halloween, 36 like the 4th of July, 36 like Valentine's Day, 6 like only Halloween, 10 like only the 4th, 14 like only Valentine's Day, and 7 like all 3. Okay, now we're ready to go. So here are my circles. So I have Halloween, 4th of July, and Valentine's Day. 7 like all 3. So I can go ahead and put that 7 right there in the middle. Now, 6 like only Halloween. So I can go ahead and put 6 right here because this is the people that like only Halloween, right? And 10 like only the 4th. And 14 like only Valentine's Day. Now, why can't I just put 25 up there? Yeah, 25 is the entire circle, right? So 25 would be all of these areas added up. So what do? So we call them X, Y, and Z, and it doesn't matter what's what. Just one of them's X, one of them's Y, one of them's Z. Doesn't matter. If you want your equations to look like mine, you'll label them like I did, but it truly won't matter ultimately for your answer. Now, that entire circle right there has to be 25. So 6 and 7 and X and Y have to add up to 25, right? Agreed? Yes. And let's look over here. 7 and 10 and X and Z have to add up to the 4th of July, 36. And 7 and 14 and Y and Z have to add up to also 36. Now, you can see why Allie was concerned when she did her homework and she got negative numbers. Should any of these be negative? No. So we hope we get positive numbers. And furthermore, we should get whole numbers, right? Not like 2.5 or something, because these are people. All right, so what do we do next? Well, we're combined. Before we do that, let's clean up these equations. So like 6 and 7 is 13. So I'm going to move that to the other side. So it's going to say X plus Y equals 12. And then the same thing here, this one's gonna say x plus z equals what? Come on, what's x plus z equal? 19. And then y plus z is going to equal 15. So there now I have, it's the same system, but it's cleaned up now a little bit. So now I can use elimination or substitution. I always eliminate, I think it's easiest, but you could substitute too. On these top two equations, what am I gonna do to my top two equations? Multiply one of them by a negative. Doesn't matter which one, I can do either one by a negative. Because then when I add them together, what will happen? These are gone. And I have y minus z equals negative 7.
Okay.
Right? And then, what do?
Just put the bottom one up.
Now, I've already, these two equations are combined into that one, but I still have this one, right? So I take the equation I got from the top two, and now I'm gonna combine it with the other equation, the third equation, and what's gonna happen to my z's? They're gone. So 2y equals 8, so y equals 4. So back over to my Venn diagram, this is now 4. And I think I can figure everything out then, because this whole ball, the H ball, had to add up to 25. Well, now I have 17 right here, so this has to be 8. And then the V ball had to add up to 36, but I have 14 and 11, I have 25. So this has to be 11? Is that right? Then I can check it real quick, because the F ball has to also be 36. Does that add up to 36, all these things right here? Yep, it does. So now I can answer the questions. That's just drawing the diagram. Now I can answer the questions. Reach in the box of students and grab one. What's the probability he'll like only Halloween and Valentine's Day? Only Halloween and Valentine's Day. So Halloween and Valentine's Day. Where are the kids that like only that? Those 4 right there, right?
Mm-hmm.
So what would be your probability?
4%.
4 over 62? Or 2 over 31, we always reduce. Why is it over 62?
Because that's how many
That's how many kids there are, and when we do probability, it's over the total, right? All right, and then the second question says, reach in and grab a kid. What's the probability that he doesn't like any of these holidays? Okay, now wait a minute. The kids that don't like any of the holidays are out here, right? How many of those are there? We don't know. How would we figure it out? So we're going to add all these up. Each of these individual numbers is going to get added up. So
672.
So how many is that? Let's see. That was 25.
60. So there's 2.
And that was 35, 46. Did you get 60?
Yeah.
So there's 60 kids in the circles, which means there's 2 kids not in the circles. So the probability of getting a kid who doesn't like any of the holidays would be 2 over 62, which reduces to 1 over 31. Okay? sorry about that typo in that problem. I'll have to really check those quizzes. I have a feeling they're all wrong, and I'm gonna do them wrong. All right, number 2. There are 30 students in Mr. Knowles' class. So we have a box of students. There's 30 of them. These kids are loving matrices and vectors. There are 2 kids who don't like either. How many like only vectors? So we have just matrices and vectors in this problem. And we know that the matrix ball is 16 and the vector ball is 24. And we know there's 2 kids out here, right? Now, if there's 2 kids out here, what is the total of all the balls then? What does that have to be? All that has to be 28, right? 28. But there are 16 and 24 kids who have raised their hands and said, oh, I like matrices, or oh, I like vectors. What does that add up to? 40? So there have been 40 votes cast. These are votes. We had 16 votes for matrices and 24 votes for vectors. So 40 votes have been cast. But there were only 28 people voting, right? Right? So if 40 votes got cast, but only 28 people voted, what had to have happened?
Twice.
Some voted twice. How many voted twice?
10.
How many?
10.
10?
14.
14?
12. Yeah.
12? Okay, this is simple. This is not hard. 40 votes were cast by 28 people. Okay, 28 people would cast 28 votes, right? But 40 votes were cast. So what does that mean? Some voted twice. How many voted twice? How many extra votes were there? Okay, guys, oh my gosh, 40 votes were cast. There's 28 people. How many extra votes do I have? 12. So 12 people voted twice. Okay, nobody's voting 3 times because there's only 2 things to vote for. You're voting for matrices or you're voting for vectors. So 12 extra votes got cast. Now, there were only 16 votes for matrices, period. So what goes here? 10? Because 10 and 12 make 16? The entire M ball is 16. 12 is already here, so what's here? 4. This entire ball is 24. But 12 are already here, so what's this? 12. Now look, what do these add up to? 12 and 12 and 4. What does that add up to? Is that what it's supposed to add up to? Yeah. There's 28 there and there's 2 here. That gives me my total of 30. So now I can answer the question. How many, this is not probability, this is just how many like only vectors? How many like only vectors would be 12? 12 kids like only vectors. That is tomorrow's quiz.